Okay, so now let's talk about complex differentiable and analytic functions. So, so we define limits, complex limits. If the complex limit they call it delta z, you can also call it h, goes to 0. So if this limit exists, then f is C differentiable at c equal to z naught. So at z naught. Okay. So yeah, let's do one simple example. Oh yeah, and if f it's C differentiable at all possible z naught, then f is analytic. Okay. So show that f of z equals c times I is analytic. Okay, so we take abstract arbitrary point z naught. Right away, we note that the function is linear. So we have I c naught delta c. So these two cancel out. And so you have I delta z over delta z, and this also cancel out. So you're left with I. So the limit exists for all z naught. Okay, that's it. And you can imagine you can have more complicated things like powers, and so every time you have to do this. If the question is asked to do it by definition, by limit definition, then this is how you will do it. Okay. All right. Some students might ask, compare this to the usual R2 differentiable from like math 291. We can write it in complex notation, this definition. It's the following. Let me write with H to make it more familiar. So the difference here is we have absolute value of H. H is a complex number, by the way. Okay, anyhow. So this is x plus iy. So to bring it home, all we're saying here is x comma y goes through the origin. All right. Okay. So let me compare these two notions with an example. the function the conjugation function, so z bar, will show that it's not C differentiable. But hopefully you can see that the function x minus y, let me write it like this, is R2 differentiable with a Jacobian matrix, right? So 1, 0, and 0 minus 1. Okay, so let's show that it's not complex differentiable at any point, really. Okay, so we have this difference. Okay, okay, let me do it at 0. So z not 0. But in fact, it fails everywhere. So we have 0, then delta x plus I delta y minus f of 0. Okay, so we have the limit. And then, yeah, so both of them go to 0. And now do complex conjugation. So we have delta x squared, delta y squared, minus 2 delta x delta y. So this is by complex conjugation. Okay, so what's the point here? Well, we have the same non-existence like we did in the continuous clip. So there's two options, right? We can take delta x to be 0 and delta y to be going to 0. So that leaves us with minus delta y squared, which is minus 1. Or we can take them to be equal. So take them to be equal and go into 0. And you have 0 plus I minus 2 delta x squared, 2 delta x squared. And that gives you minus I. And these are not equal. So the limit does not exist. And so z bar is not C differentiable, but it is R2 differentiable. So C differentiable is a lot more restrictive, and this is an example. Okay, so let me do one homework related question. So show so this is one of the questions in the book. So that this guy is analytic. So all you do is you factor it. Is analytic except at some points. So we have 2i, you factor out z, and then you're left with z minus 2 minus 5i. Okay, so as a ratio of polynomials, f is analytic except at z equals 0 and z equal to 2 minus 5y. Okay, so that's it. Thank you.